Nice. All right. So, one thing that we need to know all year for the calculator. These are not one thing. How about 4 things that we want to know all year for the calculator? We always want radian mode. So, raise your hand if you're in AP Physics. You always want degree mode in physics. So, just remember every time you come in here, calculus, we're in radians, physics, you're in degrees. Sorry, I didn't make the rules, but that's what we're always going to do. Always radians. Let's see. Another one right here. These 2, 3, and 4, these are more about calculator use. So if you have some sort of problem that's using lots of different steps, and you've got crazy decimals along the way, do not round at each step. You want to continue to use the full decimal that's in the calculator until the very, very end, and then you can round or you can truncate your answer, but only do that at the very end. So we're going to talk about storing values in your calculator. You guys might remember that from last year, like especially like law of sines, law of cosine stuff, where you're storing the number in the calculator. But at the very, very end, whatever decimal we get, we can round or truncate. I'm going to vote that you truncate. What truncate means is you just shorten the answer. So it would just be that, 43.582. Even though if we were rounding it, it would be 43.583. You can just chop off everything after the 3rd decimal. And that's just easier to do because sometimes with rounding we get in our head and like, wait, am I supposed to change 2 decimals or 1 decimal or whatever? You can just chop it off. So truncate this would be negative 0.499. That's also the same as when it's rounded. But that's a really good one. But always 3 decimal places for your final answer, unless you get an exact answer like 0.5. So if you get 0.5 as your answer, don't put 0.500, just put 0.5, whatever it is.
Literally do nothing though. It's just a placeholder.
Yeah, but just don't write them. Just write it as 0.5 because it's taking extra time. Number 2, we're going to talk about a lot once we talk about free response questions. That's going to be a whole thing that we get into probably next week. There's just specific rules with how you answer FRQs. We're going to talk about that plenty. The main thing that to remember right now is no calculator syntax in your answer. So there's different ways to justify your calculator work. It's not writing down what you typed into the calculator. So I'll show you guys how to do that later, but don't say derivative, this function, blah, blah, blah. Do it the way that I show you. And then number 1, like, it's almost always faster to use the calculator, so just go ahead and use that. And that'll be kind of a problem by problem basis. So yeah, this is all year. All year. Okay. All right. So just in terms of evaluating and how you need to plug things in certain places, these problems right here are basically 3 areas where students tend to make a mistake. So why don't you guys take 1 minute here and look at all 3 of these and type them into your calculator and make sure that you and your neighbor get the same answer. Ready, set, go. Okay. Let's check in and see how we did. Hello? I didn't unfreeze it. These are the answers that you should get. So for the first one here, make sure that negative 3 is in parentheses. For the second one, there's 2 ways that we can do it. So Gianna, with your TI-83, you have to do it this way right here, parentheses, because you can't do this fraction right here. But everyone else, I would recommend, well, actually, the TI-84s, some of them have new software where you can type the fraction right here. Some of them don't. So there's 2 different ways, but we want to make sure that we are dividing 7 by 2 times pi, or 6.28 basically. So does everyone know how to do the fraction in the calculator. Does anyone need to see that up here? Okay, yeah, so the way that we do that is we press alpha and then y equals, and this little menu will pop up. If this menu doesn't pop up and instead you go to like the y equals menu to graph something, it means that your TI-84 software is not updated. And you can do that somehow, and I can figure that out, but yeah, Cav.
Can't you also just press alpha and then the xt theta n?
Probably. You're probably right. Alpha, yes. You can also do alpha x, yes. That's the fast way to do the fraction. Nice. This is how old I am. The TI-84 didn't have the fraction option when I was in high school, so I had to use parentheses. So I actually don't know all the tips and tricks, but yeah, that's good. Alpha x will also do it. So when we type this here, we can do 7 and then 2, and the pi button is here on the caret, so you have to do second caret. Second caret, boom. And that's how you get it underneath. So I recommend that that's how you always enter your fractions there. And then lastly, 47 to the 9th power, you just use the caret to raise it to the 9th power and then arrow over so that you get that answer here. You'll never get an answer that's this big on the AP exam, so you don't have to worry about writing this as like 1.119 times 10 to the 15th power. You just won't ever get a number that big on the AP exam or any of our tests, so we're not messing around with that. That's more of like an AP chemistry kind of number that you would get. So, or just regular chemistry or honors chemistry or whatever. Any questions on these?
What's interesting is that the second one, if you just do 7, you just click, then you click the normal divide button over 2 pi, you'll get something completely different.
Right, because what this is doing 7 divided by 2, which is 3.5, times pi.
Oh.
And so that's the same as 3.5 pi.
Oh.
Yeah. But we want to do, so if you're going to divide, make sure it's in parentheses like that. And actually, this is good to know. You can be a little bit lazy. You don't have to close that parentheses right there, just so you know. So it could save you 0.5 seconds here and there. Okay. So let me just add in here, use fraction right there, parentheses around that. Those are the main ones. The third one's probably not too bad. Okay, this one right here. Typing sine squared theta into the calculator can be tricky. Why don't you guys take a minute and see if you can get the right answer for that, and then I'll show you how to do it. Okay. Looks like we need some guidance on this one, and that's okay. So, first of all, when we see f of 2 over 3 pi equals sine squared theta. This is a weird way to write it. Let me just say that right now. I remember this from last year now. So it should say f of 2 over 3 pi for f of x equals sine squared theta, or if f of x equals sine squared theta. So this is a weird way to write it. Don't write things like this. That's weird. Why is it typed like that? I don't know. So what does this mean? F of 2 over 3 pi. What are we supposed to do with 2 over 3 pi?
Convert to degrees.
Convert to degrees? No, we're not supposed to do that.
It's supposed to be theta.
It is supposed to be theta, yes. So what we need is to evaluate sine squared of 2 over 3 pi. We are supposed to substitute that in. Now, you probably found very quickly that you can't type it like this on the calculator. You can't put that squared in between the sine and the 2 over 3 pi. But the way that you type it on the calculator is like this. This top one here is how we want to do it on the newer ones. So you just put the squared after the parentheses. It is squaring the whole thing. It's sine of 2 over 3 pi times sine of 2 over 3 pi. If you can't do the fraction, you just want to do 2 divided by 3 pi. 3 pi there in parentheses. Close the parentheses for that. Close the parentheses for sine, and then put the squared right there. And just as a reminder, sorry, I have to change to the mouse here. Just as a reminder, this is the same as sine of 2 over 3 pi times sine of 2 over 3 pi. That's what sine squared means. It means sine times sine of the same thing. So all three of those are equivalent. Definitely don't type this. Type this top one here, but that is what that means. So let me just write that down in the notes here. Sine of 2 over 3 pi squared. That's what you need to type. This is one that folks forget about all the time. Don't forget about it. Just as a reminder, there is a quiz on Friday where you'll be quizzed on this calculator stuff. It's probably a coincidence that I mentioned that right after I said, remember this one, don't forget how to do it, right? It's probably a coincidence, I don't know. Remember this one. Anyways, let's talk about graphing. What do we press to graph on a graph? Oh yeah, Cal.
How do I write cosecant?
Oh yeah, you're right. We should talk about that one. So f of x equals cosecant theta. Find f of pi over 5. This is how it should be written. There is no cosecant button. Cosecant is equivalent to what? 1 over sine. So what we want to type is 1 divided by sine of pi over 5. Yes, good catch. So you can write it like this: 1 divided by sine pi divided by 5. Whoa, not like that. Sorry.
Can you use the fraction thing as well?
Yes. Absolutely. For a simpler fraction, I tend to just use the division sign. But we could also write that as 1 divided by sine of pi over 5. Yes. So that would be our cosecant value. Same thing with secant or cotangent. We would have to use 1 over the sine, cosine, or tangent function. Okay. All right. Questions so far?
For that one, do you have to use both the parentheses or only for the power of 5?
You could. Yeah, we probably don't need these parentheses. We could delete, and actually this one too we could delete, and it will give us the same thing. It just automatically put it in there. Yeah. Okay, so to graph on a graphing calculator, what do we press? Y equals. Yes. So we press y equals. This first function here, we're going to graph x squared minus 4. X squared minus 4. Oh, if yours says R, then you are in polar mode, probably from last year in pre-calc. So go back to function mode, and the way that you change modes, and this is for anyone, the way that you change modes is you just arrow down to whatever you need. So if I wanted degree mode for physics class, I would just arrow over to degree and press enter. Calc BC, we're going to mess around with parametric graphs, so we'll click parametric. But function is the one that we want for y equals. Yep.
Wait, how do you get to the menu where you can switch between degrees and rate?
Mode. Press the mode button right here.
Oh,
Yeah.
yeah, I see.
Okay, so let's take a look at our graph here, just for funsies. Hopefully your graph looks something like this, but depending on what your window settings are, you might be seeing a different part of this graph. So to change the window, what button do we press? Window. Yeah. Okay. So x min and x max. This is like how far to the left and how far to the right we're seeing.
An error.
Ooh. Yeah. So press. Your window's probably screwed up. Oh. Okay. Yes. Let me talk about that too. So there's like a million little things that can happen with these calculators. So if you're an AP Stat, you're going to be using the stat plot a lot. And if I go arrow up to that and press enter, and I try to graph, I'm going to get an error because there's nothing in my stat plot. And so if you ever get an error right when you try and graph, check and see this rectangle here is darkened. Just go up to it and press enter. The other problem that could happen is my window could be messed up. So for example, if my x min is 10 and my x max is -10, this is telling me the smallest number is 10 and the biggest number on my x-axis is -10. That's backwards, right? It's not going to work when I try to graph. It's going to say error window range. So anytime your window is screwed up, which could just happen by accident, you just have to go and fix your window. So
How do you fix your window?
So we're going to change the x min and x max. So the default is -10 to 10. Oh no, my battery. The default is -10 to 10, but you can change it to whatever you want to see whatever you want. So if I want -100 to 100, that's the x min and x max. Notice how skinny the graph looks because all of a sudden this is -100 and that's +100. Or you can, zoom in however you want. You can do -4 to 4.
I think my calculator's carrying a similar issue as well.
Yeah, did you turn the stat plot off? Just make sure your window makes sense. So this thing here, x scale, what that does is that just tells you how often to put a tick mark. So if I wanted to count by 2s, notice now these two dashes are 2, 4. This would be -2, -4. So that's what that does. I never really mess around with that, but that's just what that is. Y min and Y max we can change similarly. You can just set it to whatever you want. For word problems, we are going to want to mess around with the window to make sure that we're seeing the right part of the graph that we're seeing. And there's an example later on, so we'll look in more detail. But we've got this graph here, and it's x squared minus 4. And we need to know, we want to know what this equals when x equals 3.2. Now, could we just do this? 3.2 squared minus 4. Is this the answer that we should get? Yes. But imagine it's something crazy like e to the pi sine of x squared minus root x or something like that. Imagine this is your function and you want to know this is at x equals 1.23456. Okay? This would be really annoying to just type in the main screen. So the better way to evaluate this is what we're going to do is we're going to press, there's two ways to do this. You can either press alpha trace. Alpha trace. Oh, wait, sorry. I know. I have the marker on, so it's just drawing on the calculator. Alpha. Hello. Alpha trace. And, oh gosh. It's because I used the pen, and so there's just like little pen marks all over the calculator that I have to keep deleting. Alpha trace. There we go. And now it brings up this menu right here. So y1, y2, y3, y4, etc. That's just whatever you have typed in as y1, y2, y3. So what we want is y1, because that's where our function is. And then we're going to do y1 parentheses 3.2 and press enter. So this means plug 3.2 into whatever the function is for y1. So this is really useful, especially if the function is super complicated. So again, that's alpha trace is what brings up this y menu. And you might have 2 or 3 functions typed in there, and you probably will for some of our more difficult calculator questions.
And I press alpha.
Yes, yeah. So the other way to do that is you press vars, that red button right there, and then you go over to y vars, y variables, and then we're in function mode, so we press enter, and then you choose from here. Yeah.
Still have any issues as error invalid to measure when I'm trying to like graph something?
Yes, I remember you probably have to turn off your stat plot.
Wait, how do I turn it?
See how that's on right there? You have to
Yeah.
go up and press enter.
Oh.
If we ever need to add two functions together, like we can do that from here. We don't usually have to do stuff like that, but there are sometimes, well, there's nothing in y2, so that was silly, but we can mess around with different functions right here. This will help us when we do derivatives and integrals of the function. We can just use y1 and y2 as our variables. So let me go and type that here. So y1 is going to equal x squared minus 4. We're going to press alpha trace, and then we're going to type in y1 parentheses 3.2. And so that's the quick way to do it. Or we can press vars y vars and then function. So you guys try that for the second one. Just go to y1 and type in tangent inverse of x. So you don't have to use theta. You don't have to be in polar mode. Just use x. And then you want to type this in your calculator screen. Do we get this?
Did you do 10 negatively or 10?
So I just changed y1 to tangent inverse. You could make it y2 and do the same thing with y2. It doesn't matter. But then I'm just doing y1 parentheses pi.
Second 10.
Questions? Okay, cool. We're gonna do maxes and mins now. So go ahead and type this function in for y1. And I will do the same. Okay, so we should get a graph that looks like this. And now actually, I zoomed out, but I'm gonna zoom back in here because I noticed some details on the graph a little bit better. Whoa. Oops. By the way, if you ever, here, let me show you what I mean. Let me show you. So that's what this graph, this calculator graphs things really quickly. Sometimes your calculator graphs things pretty slowly. For example, if I typed sine of x and I start graphing here, let me go into, am I in radian mode? Yes. Let me change it to degree mode. Oops. Oh no, here's what I want. This is taking me longer to prove this point that I'm showing you guys, but it's helpful. Let's say I was trying to graph sine of x and it like fills it up right here, and I'm like, oh crap, I'm supposed to be in degree mode, and actually I'm in radian mode, or vice versa, or I typed something wrong, my graph's wrong. That's the fastest I've ever seen a calculator graph a function, by the way. So whose calculator graphs things slower than mine? Raise your hand. Your graph's really slow. Okay. So it can be really annoying. It's like doing this, like, and you're just like, come on, like, oh, I'm trying to, I know it's wrong. I know I made a mistake. I need to retype it. Press the on button to pause your graph. And then you can press Y equals and fix it. So it'll just stop your graph in the middle of whatever you're doing. Yeah.
Oh, my graph was a box plot for some reason.
Whoa, that's crazy. I don't know. How did you do that? Oh yeah, because you have Plot 1 on, but you actually have stuff in Plot 1. Are you an AP Stat?
I was, yeah.
You will.
Last
Okay,
year.
yeah. So it's like just left over from last year. Here you
Oh,
go.
okay.
Yeah. So being able to pause the graph partway through is super helpful if you realize you've typed something wrong. Okay. So, whoa, what the? Okay, so let's look at this one. We need to find the maxes and mins, and we'll just do the zeros on this one too, so that we don't have to, well, oh yeah, that's the second question. So we're doing maxes, mins, and zeros. As we look at this, the word for maxes and mins as a whole is extrema. How many extrema does this graph have? How many maxes or mins? How many? Turn to your neighbor. How many? Okay, 3 is correct. There are 3 maxes or mins. There is a minimum here, a maximum here, and a minimum here. Now this bottom one happens to be the absolute minimum. That's not what we're talking about here. We're just talking about relative extrema. So 2 minimums and a maximum. We are going to be able to use calculus to find the values of those things very soon. But also sometimes you need to do that on the calculator. So the calculator can do that. If I'm trying to find a minimum, I'm going to press second trace. And you can see actually we're about to use this menu for a few things. It can find zeros, it can find minimums, it can find maximums. So if we want a minimum, we're going to go, you can just press the number 3, by the way. If I just press 3, it selects that. And my little cursor pops up. So watch what I do here. Don't just look at my screen if you don't know how to do this. To find a minimum, let's say I want to find the first one. It says at the bottom of the screen, left bound. I need to arrow over so that the cursor is to the left of the minimum. Then I'm going to press enter. Now it's asking me for the right bound. So I'm going to arrow over to the right of the bottom. It doesn't matter how far to the right, except do not go past. I don't want to go past this maximum right there. That's going to confuse the calculator. So I want to go here, anywhere to the right of that minimum. So it's getting me to select to the left and to the right. And now it's asking me to guess. Hold on just a sec. The guess does not matter. You can just press enter. But just for fun, if you want to guess, you can. You're not going to get it right because the pixels are not going to let you get it exactly right. But you can guess for fun. But you can put this cursor anywhere for the guess. You just press enter. Hello. What happened? Did I press minimum? Minimum? I've never seen that before. Left bound, right bound, enter. Okay, it worked that time. And it's telling me the minimum. So what would be the minimum? Would it be negative 0.3 or would it be 2.7? Yes. So we would say the minimum is 2.788. And if I asked, okay, where is the minimum? You would say, oh, it's at x equals negative 0.3. So remember, the minimum is the y value. I forget what it was. What was it? 2.788. Okay, and remember, it's points 2.7885. We don't have to round, just chop it off. 2.788. There's another min, and there's a max. Okay. Any questions on that process, Aiden? Aiden.
Somehow can you go back to your calculator?
Yes.
Mine like looks a bit different.
Your window is different than mine, so it's just stretched differently.
Oh.
Yep.
No, like it doesn't say minimum or the equation thing.
Did you follow the steps that I showed? So you have to press second, trace, and we're going to do min or max. So you guys can write this down too. And we have to press left bound and right bound. So what that's going to look like is you are pressing enter on either side there. And again, for the third thing, the guess doesn't matter, just press enter. So we have to click to the left, to the right. So you guys do that for the other min and max on that graph. Caleb.
Do you want us to tell you? Do you want us to tell you exactly where the minimum occurs? Like, do you want us to say minimum 1 million y equals 2.788 at x equals negative 0.312? Or do you want us to just tell you? Oh, there's a minimum here.
So it's going to kind of depend on the question. For right now, you can just say the y value is fine. Yeah. I know last year, yeah, we were a little bit pickier. We will be similarly picky this year. For right now, you can just say the y value. So find the other minimum and the maximum, and then I'll show you guys how to find the zeros. And let me know if you need help with that. You might have seen that intersect option on the menu that we were just looking at. So once we have those two things typed in for y1 and y2, it's in the same menu. So it's second, trace, choose the intersect option, and then you can actually just press enter 3 times. It's going to prompt you with first curve, second curve, guess. Again, the guess does not matter. This one here, I'm suspicious that there are 2 intersections. I can't quite see it on my window, but it looks like they might hit each other again. So I'm zooming out. Now I'm noticing, okay, I zoomed out a little bit. These are definitely not going to intersect because the blue graph is x cubed, and so it's going to be much steeper. Whereas this is x squared, it's going to be shallower. So as this continues to grow down this way, more and more shallow, the x cubed is going to go steeper and steeper. So now I'm confident that they will not intersect. But if I was still more suspicious, I could just mess around with my window. Okay, I need to look down farther. Maybe I'll go look down at 100. Oh yeah, they do spread out. They're not going to hit again. So again, it's second, trace, intersect is the 5th option. First curve, doesn't matter which one. Press enter. Second curve, enter. Guess, doesn't matter. Tells us the intersection point right there.
Could you explain that again?
How to do it. Second, trace. Press 5 for intersect. Press enter 3 times. Kev.
If you have multiple intersections, does the guess matter more?
Yes, it does. Whichever one you're closest to, it will give you that intersection. So yes, that is a really important point. If there's 2 intersections, move your guess closer to the one that you want. You probably want both, depending on what it is. I will write that down. Yes.
How do you get
Yeah, so when it says the third option for guess, you just move it closer to where it is. So let me write that down, and then I'll show you an example. So if you have multiple intersections, you need to guess closer to the one that you want. And actually, that we might do that in the next one here. Let me change. Okay, so yeah, I'll look at that in just a sec. So if we solve, I'm going to change this problem here. Let's make this x squared plus 4, negative x squared plus 4 equals 5. And then I'm going to say negative x squared plus 4 equals negative 2. So we have two equations we're going to solve here. So, same deal when we're solving an equation. It's the same as finding the intersection between them, between two graphs. We are going to make the one side of the equation y1, and we're going to make the other side y2. Oh, and it doesn't matter which one's y1 and y2, but put them both in. So I have negative x plus 4 in there already, so I'm going to put 5 as my first graph. I can see that they don't intersect. So what's my answer? No solution. So this one has no solution.
Wait, how do you do the equal sign?
You don't. You do the two f's in as y1 and y2. Okay. The other one is going to have some solutions. Instead, I'm plotting negative 2 as y1. We have two solutions, so this is, Sarah, your question. This will show you how to answer it here. So when I do, it's the same idea. I need to find the intersection here. Second, trace 5, enter, first curve, second curve. Now when I guess, if I want to guess the left intersection, just scroll closer to the left one than you are to the right one and press enter. If I want the right one, I do second, trace, 5, enter, and then just scroll closer to the other one over there to guess, and it will tell me that one. Okay. Next, we're going to look at storing variables. So we can see here x equals sine of pi over 7. That's going to be a pretty complicated decimal. And we want to know what 3 to the x minus 2 root x minus 4x equals. So the first thing we want to do is type this in the calculator. Sine of pi over 7 store as x. And actually, Using a different letter is better. So I might actually store this as A instead. And I'll show you guys how to do that. But then once we store that as A, we're just going to type this in. 3 to the A minus 2 root A minus 4A. Okay, so if you're not sure how to type that into the calculator, look up here. If you do know how to do that, you can just go ahead and do that. But if I'm doing sine of pi, divided by 7, the store button is right above the on button right there. I'm going to store that as A. So I have to type alpha A to get that. Now that's stored as A. And then I can type 3 to the A minus 2 root A minus 4A.
How'd you store it as A?
So this button, that you see the red highlighted button right there? So that'll give you the little arrow to store. So I typed sine pi over 7, then the arrow, then typed A.
Where's A?
You can press alpha, and then you can do any of the letters.
Oh.
Yeah. So, and the reason that X isn't really good to use, you just have to be really careful with it. So let's say I take 45 and store it as X. If I, and I do, let's see, what's 2x? Like, hopefully it's 90. Yes, it's 90. Let's do x minus 5. Hopefully it's 40. Okay, it is. But if I go to my graph and I move this arrow around right here, and I come back and press x, now suddenly x is 2.045. Where did that number come from? What's that? Where it was on the graph, exactly. Wherever this little cursor is on the graph, that is going to override whatever value is there in for x. So right now, x is going to be 2.78 because I'm moving around. It's the same is true with y. So you have to be careful using y as a letter as well. It won't hold its value if you go to the graph and start scrolling around. So just be careful with that. Okay, any questions on storing? All right. I'll say we'll skip this one, but this is good practice. But we won't do it because I think you guys know how to store things, and I know that how to use a calculator is not the most interesting lesson in the world. What I want you guys to do right now is I want you to take 2 to 3 minutes with your neighbor, read this question, and talk about what you would need to do with your calculator, with your graph, in order to answer that word problem. Ready, set, go.
Should be 20 meters. I don't think my Y is measured. I started at 0.
T is 0 is.
Okay, take about 30 more seconds, and we'll talk about this as a class. It's got a lot of different pieces in here. 30, I think.
I think so. You might have to modify it so this is like plus 20. If it starts at 20.
So it starts at 20 and then goes up and then.
Well, you can probably zoom back to 3.
All right, let's talk about this. So, what this is the question that would be posed with an FRQ on the calculator section. And then there would probably be, this is probably part A. And then there would be part B and part C and maybe a part D asking you different things. So, what you might notice is that to answer the question that we actually have more information than we need. You might have noticed that. And if you didn't, that's okay. So, what is this function measuring? The rate of production. Okay, so we have some sort of cave. That's my cave. And inside the cave, we are making methane. And this function is telling us the rate of production. How fast are we making methane? What's the next thing that we're told about this situation? What's the next number we have?
Is that the initial amount when it's the initial amount of methane at the start is 20 liters?
Okay, nice. So we've got 20 liters of methane in here already. Okay, then what happens?
At about 8 hours, there's a pump that begins to move methane out of the cave at about 1.5 liters per hour.
Yes. Okay. So suddenly, at t equals 8, we start removing methane at 1.5 liters per hour. Okay, so this is the whole situation. Methane's in there at 8 hours. It starts being removed. This is a classic calculus question, one that we'll probably come back to. Part A, or the question that you guys have, is asking us, at what time from 0 to 8 is the amount of methane increasing most rapidly? So based on that, what is the unnecessary information that we have to answer part A?
What happens after t equals 8?
Yeah, we don't need that. That's later. What else is unnecessary?
The initial amount of methane at the start of the body.
The initial amount is also unnecessary. Because if you think about this, just like, there's 30 people in this room right now. If 100 people walk in, the rate of increase is like 100 people a minute or whatever. If there's no one in here and 100 people walk in, the rate of increase is still 100 people per minute. So it's
It's just that we start in a different spot.
Exactly. So the rate is unaffected by how much is initially there. Okay, so the only thing we need is this rate function, and we are looking for when the amount, where the rate is increasing most rapidly. What's another way to say that? Yes. So what we need is the maximum of the rate, and what is the function for the rate? Yeah, so we're going to need to find the maximum. What function represents the rate? This one, yes. So we are looking for the maximum of R of t. So now we know what to do. We graph R of t, and we find the maximum of R of t. But it takes a little bit of interpretation to get what we need to do. So we're going to go to y equals, and I graphed it already. What's something that I would want to change? The window, yes. What would I want to make my window?
0.
Yes. So x min 0, x max 8. And if I'm feeling fancy, I could also make, bless you. I could also make my y min 0 because I saw it was always above there, so we have a nice pretty graph. Okay, so this is our rate from 0 to 8. You guys see the maximum on there? We need to find that maximum. So second trace, maximum, and away we go. 2.718. Whoa. What number is that the maximum is? The maximum is at x equals 2. What is the maximum? 2.718. Does that number look familiar to anyone? It's math trivia. E. Yes, that's E. 2.718. Nice. Okay. So when we're answering this, at what time t is the amount of methane increasing most rapidly? T equals 2. Yes. What we would want to say, because that number is rounded, we would want to answer it. We would want to say the amount of methane. This is good practice for FRQ. Is increasing most rapidly at t equals 2.000, because we did round that number. It wasn't exactly 2.
Can you say at, or do you have to use the at symbol?
You can say at. Sarah.
When I did it, I got 1.9.
Ooh. That's strangely close, but different. So interesting. Whoa. I don't know. Did anybody else get 1.999 for their t equals? Yeah, I don't know.
It's the guess that, yeah, I moved my guess around and it got me to 2.000.
Weird. Weird. Well, the good news is both of those do round to 2.000. And if this were an AP question, or if it were me grading it, and I knew that there was a possibility the calculator could give you more than one answer, you both would be correct. So that's kind of strange that the calculator does that.
When do you round it versus just like?
You always have the option to round or truncate and chop it off. So I vote that you just chop it off because it's easier. You always have the option. Okay. Whew. That's it.